Hey guys, it's Simon and welcome back to the LibGDX Kotlin RPG tutorial series. So in the last 3 parts we covered quite a lot of stuff regarding Box2D. We are creating now already entities, we can move the entities around, we are currently colliding with the different slimes, and also our camera is now locked to our player that we can move around in the world for the time being. And also we have an interpolated rendering, so we have a very smooth experience when it comes to rendering. Even if we would not update our physics world 60 times per second, which we currently do, we would still have a very nice rendering experience, which is important for our players. And what we currently don't like a lot is that our bodies are way too big, as you can see it here, because of the graphics that we are going to use. And we depend on that, and instead of fixing now the graphics itself, we are making a small configuration adjustment that for whatever graphic we get, we can then simply adjust our physics body to match the correct boundaries of the graphic. Let's say that we have a very intuitive hitbox for the player as well. So what we need to do there is in our spawn configuration. So when we go to a spawn component, we need additional information. So one information is our physics scale. So physics scaling, which is actually could be scaled in both directions, and per default it would be 1. So if we don't want to change anything, then it's 1. And another thing that we need is a physics offset. So what is that? Let me show that to you in a moment as well. And the offset by default would be 0 because we don't want to offset it at all. So those two settings, what they are doing now, not yet, but we implement that now. So they will scale down the width and the height of our body so that it gets shrinked in our case to match the graphic. And also, as you see here, so there's a little gap between the body of the player and the body of the physics body, and in case that needs to be adjusted as well, so we need to maybe move it upwards, right, left, or even down, could be anything of that. That is then described in the offset so that it really then is correctly adjusted and linked to the graphic. So those are those two settings that we can introduce. So in our spawn system, where we are currently creating those different spawn configurations, we now need to add additional info. For example, for the player, the value that I used, so for the physics scaling, I used for the player, for example, that it's only a third. So yeah, a third of its original size. So that we saw before in the rendering. And also we have an offset here, and the one that I used here is 0 pixels on the x-axis and -10 on the y-axis, and that one needs to be multiplied with the unit scale. Then it's really, from what I remember, this is the pixels, how many pixels I want to move up to match my graphic. And for the slime, let's also copy that down to the slime, because also that one is not perfectly aligned. So there also the scaling, again, what I used was 0.3. That looks good, but here I don't move the body by 10 pixels. Here I only need to do it by 2 pixels. Okay, and in the end, so up there where we create this fixture for our body, that one we now need to adjust. So the width is now the width that we get passed in, which is the image width, but that one we need to scale with the physics scaling, and the same with the height. So there's from the height, and also with the physics scaling on the y-axis. And then our box is not the width, it's then simply just the scaled width and height. And we also want to have an offset. and there we pass in the physics offset of our configuration. And now let's see. So now those boxes of our physics world should be way closer. Yeah, perfect. So here you see now with those adjustments, so now we are scaling down the body, and also with the offset we can play a little bit around with that, but I was very happy with that. So that the hair, for example, of the player, that one will not detect any collision. Also the shadow below will of course not detect any collision. It's really inside of the graphic a little bit, which is, yeah, I think that that is way better. And with those two configurations, so the scaling and the offset, you can adjust the created box 2D bodies in that specific game that we are going to develop to match the graphics better. So this is just a little bit playing around with that values so that you get the perfect matching out of that. Good, and now the next thing that we want to fix now is that our player actually moves around the slimes. This is something that we don't want. Also, just in case you are wondering, so I just noticed that there's a warning that we never use this physics component in here. Right now we don't use that, but that one we going to need when it comes then to the attack system and to detect what kind of entities get damaged. So that's why we prepared that already. So in case you are wondering why did we introduce that, we are not using it. We are going to use that then in the future part. So this was just some preparation work. But continuing with what we want to achieve in this part, we are going to enter our physics system. And now this physics system is going to become a so-called contact listener. And then it's our constructor where we have the physics words. We set the contact listener where you can only set one contact listener, and that will be our physics system itself. And we are going to implement all of these methods which are important. Let's move the companion object to the bottom. Okay. So in Box2D, when you have a contact listener, then you can listen and also react to collision events or contact events, whatever you want to call them. There is a begin contact method, which gets called when a collision is happening. There is an end contact method, which gets called when a collision is resolved and two bodies are not in contact anymore. Then there is a pre-solve method, so before you are trying to solve the contact, and a post-solve method, so after you are trying to solve the collision handling. And we are going to implement something for a few of these methods, and I show you also different scenarios, and I will also explain different things what you can do when it comes to collision handling and interact with that or do something with it. So in our scenario where we simply want to disable the collision between the player and the slimes, we can do something very, very simple. So begin contact and end contact, we don't need that for the time being. Pre-solve and post-solve, post-solve we also don't need that, so that one we will never implement that and never use that, so we can simply set that to unit. We don't have any code for that. But our pre-solve method, there we want to do something. There is a flag or attribute which is called isEnabled, and that one defines if a contact, so if a collision handling should happen or not. So for example, when we set that here to false, the contact can never be null, so we can remove here the question mark. I think also the manifold can never be null. So when we set this contact is enabled to false, which means for whatever contact is happening in Box2D, isEnabled is always set to false. What does that now do? This is now doing exactly what we want, because we want to move through the slime, so we don't want to move them around. So this enabled defines if a collision should happen and if box2d should use its collision resolving logic or not. By the way, also what you see here is the sorted rendering, so that the player is now in front of the slime, and when we move him behind that, then he's drawn backwards of the slime. So this is also something that I could never show so far, but our render system and the sorting is taking care of that things are rendered in the correct order. But anyway, for us, the important part in this part is the physics system. This is enabled stuff. And of course, we don't want to simply disable the collision handling completely, because in a later part, when we are going to create collision objects for the fence or for the stone, for example, then we don't want to pass through that. So simply setting this flag to false is not going to do it for us. Instead, what we want to do is that we use a little bit, not really a trick, but let's say a certain setup that we chose for this game. So all our entities that should not have a collision have actually a dynamic body. So our player and the slime, they have a dynamic body, and all the collision stuff and also the chest later on, they will have a static body because they don't move around. So our logic is that when two dynamic bodies are colliding, then we don't care and enable is then set to false. And if any of the contact bodies is a static body, then enabled will be true. Oh, and also maybe as an additional note, so the collision of two static bodies should also not happen. That could happen, for example, if what we introduce in one of the upcoming parts, when we automatically create collision bodies out of our world. So for example, in tiled editor, we will create a collision for the stone, for the tree, and then maybe you place a stone in front of the tree. Then we would have a collision body for the tree, and inside we have a collision body for the stone. And there we don't want to apply any collision resolving algorithm, let's say. So that's why we also don't apply there a contact. So in our case, we really only want to have a contact when one of the bodies is a dynamic body and the other body is a static one. So we have two things. So from our contact, there we have the information of the fixture A, and the fixture is linked to a body, and the body is linked to a type. And if that one is a static body, and from our context, the fixture B, body type is a dynamic body, then we want to have it enabled. Or let's put that into the next line, or vice versa. So the body B is a static body and the body A is a dynamic body. So let me introduce here some static imports that it gets a little bit shorter, and this is still quite long. So let's make here some utility functions again. So extension functions in Kotlin. So we have a extension function on a fixture, and let's make it here is static body, and that one is simply from the fixture, the body type equals static body. And then let's add another one. Let's call that is dynamic body, and that one returns when the type is a dynamic body. Then we can write that a little bit easier. So this one is a static body, and fixture B is a dynamic body. And the same thing here below. Let's also fix that here. So fixture B and fixture A. And now we can move it here up again. Then it's a little bit easier to read, I would say. So now we should not have any contact between the player and the slime, which is great, which is what we actually want. But in the next part, when we introduce then collision objects, then we will still collide with those static bodies. So this is what we want to have, and this is one way how to handle the collision behavior in Box2D. Another solution would be that Box2D out of the box supports certain masks. Let me quickly open up there the documentation. So it's called collision filtering, and there you have category bits, mask bits, and group index, and with all of that stuff you can assign a specific body, a specific category, group, or mask, and this is then some bitwise operation and super fast to know if something should collide or not collide. The downside to that is that you are limited, so I think you can only define, like here, up to 16 different categories and masks and so on. And another downside that I see is that it is very complex to understand, because when you read through this documentation, and there is some example with different ships, so a friendly and enemy ship, and I think something is flying and something is on the ground and things like that. And they solved it then with those different masks and categories. So this bitwise definitions, and of course great if you understand that, and super fast if you define it that way, but I always found that a little bit confusing and not that intuitive to understand, and also you can mix up those masks very easily and break everything. So that's why I prefer to do that in the code, and that's why I use personally always this pre-solve method with the is enabled flag to say if something should collide or not. But just that you have heard of that, you can also do that out of the box in Box2D with those different categories, masks, and whatever setup, which you could also use to achieve the same goal as we did it programmatically. Okay, and to see that our collision with static bodies is working, I would say that we quickly introduce also the chest entity. So in tiled, I'm going to add here and configure now our tile set. Maybe that's a good exercise to do it together. So here I add a new graphic from the assets folder, from the images, and there I add now the chest. Then in our map, we are going to introduce a new type. The new type is called chest. And we are going to place a chest component in our map. By the way, when you hold down the control key, then the image is, how you say that, it's then bound to a specific tile. So if I don't do that, I can freely place it around, but when I hold down the control key, then it's always correctly locked inside a tile. And let's, for example, put the chest here, and then let's also move our slime here a little bit below, so he later on will defend this chest, and the player has to defeat the slime to get this chest. But that's it for the time being. So here we have our chest. What we did not do yet, so we need to give it a type. And that's it. So now we need to go back to our entity spawn system. We need to go to our spawn configuration method. And there, when we get a chest, we create a new spawn configuration. So the animation model is the chest, which we already have available. Here we can now set this, how did we call it? Speed scaling. Exactly, so the speed scaling to 0, so because our chest does not need a move component. So that is done that way. And also we need most likely a physics scaling again. Let me quickly check. Seems like here I did not need that, because I think the chest is really a 16 by 16 graphic and not bigger, so it's correctly aligned also with everything that we have, so we don't need that. But what we cannot do at the moment, let's also quickly change that. We cannot define what kind of physics body gets created. So in our spawn component here, let's create something new, which is the body type, which is the box2d body type. And by default, it is, for example, a dynamic body. But for our chest, we don't want that. So there we want to have a static body. Okay, and then up there, where currently we always passed in the dynamic body, we now take the body type from our configuration. Okay, theoretically that should be it. Let's see. So we already see the chest, which is a good sign. Also, we see here a body and it's green, and we cannot walk through that. So the collision between a dynamic and static body is perfectly working, and we can still move through dynamic bodies. So that's great. Everything is working as we want it to be. And you also have now seen it's not that difficult to add a new entity with the setup that we have chosen so far. So we are very flexible and can easily extend that. Perfect. Okay, yeah, that's it for that part then. So this is a way how to define what kind of entities should collide. And again, I use this is enabled attribute on the contact, and I don't use these masks and categories that box2d would provide, but just that you have heard of it, it would be available and you can use that. And I think even in my Mystic Garden tutorial, so the Java tutorial that I did, there I think I used these masks actually. Okay, that's it. Thanks for watching and see you in the next one. Bye bye.